Hello. How's it going?
Great.
Thanks for having me here in my microphone. So I'm going to talk about this project Deno. And I'm just curious, have you guys heard of Deno? Do you know what it is? Vaguely? Have you used it?
No.
OK, that dude. And of course, him up there. Those guys. Yeah, so anyway, before I talk about this, I have to give a disclaimer, which is that this is a talk aimed at people who are very, very interested in JavaScript and very, very interested in exploring the world of possibilities out there with this software and are comfortable with experimental projects that you can't currently use at your company. I am not suggesting you use this. And I would just like to remind you that Node is very stable, will continue to be stable, and that you should all keep using it. And I don't want to suggest otherwise here. So, if you're making a website, please just continue using Node. And ignore this talk. Don't worry. Don't get into an existential crisis and wonder about how you're going to migrate your code base. This is a very long ways away from that. So this is just exploring the possibilities. So Deno is a new command line runtime that is very similar to Node in many ways, but quite different. Hopefully I'll explain too. And it executes JavaScript like Node, but also TypeScript kind of out of the box. And it's primarily built on top of, just to kind of orient you in the world of software, it's built on top of V8, which is the JavaScript interpreter VM inside of Chrome. Same thing that Node is built on top of. A very large and advanced piece of software that makes all of these sort of experiments possible. And then kind of instead of using C++ like we did in Node, we're using Rust. And instead of libuv, does anybody know what libuv is? Or is this just OK? Well, oh, sweet. So, for you 5 people there, the equivalent library that we're using is called Tokio. Quite nice. I'll just throw that out there without further talking about it. And then, of course, we use TypeScript, the TypeScript compiler from Microsoft, which is written in JavaScript, but is kind of compiled into this whole jumble of stuff. So, kind of the intersection of this software is kind of where we are in the world. And yeah, the first question is why? Why do you want to do this? Isn't Node OK? Like, what is actually wrong with this? And why change things up? This just causes confusion, right? Like, doesn't this cause like a Python 3 situation? And yeah, I'll refrain this time from ranting about Python 3. But yeah, so I would just say that it's not clear that doing a new project like Deno is the right thing to do. It's an experiment, an interesting experiment, but an experiment nonetheless, and not clear that this software would actually be successful and anybody would use it 2 years from now. That said, I would say that Node was designed in 2009, and the language of JavaScript has changed very much since then. Notably, like in 2009, JavaScript didn't have typed arrays. There was no way to access raw binary data. Like, we were doing like TCP sockets with just strings and trying to like somehow encode binary data into this stuff. Total madness, right? Now we have, for many years now, have array buffers, typed arrays in JavaScript. We have this async await stuff, which is particularly relevant to the asynchronous nature of JavaScript. And kind of the core idea around Node being that it's all non-blocking I/O. Async await makes this all very much easier to program with. Instead of callbacks, you can block stuff. I assume you guys all know about that. And then there's this ES module stuff, this new module system. They're replacing require with import, right? I think it's quite a nice design, and there was a lot of thought that went into it. Require was basically just invented by me to kind of solve a loading problem, right? There's not a huge amount of thought that went into it. The thought was more focused on the kind of asynchronous I/O part of it. So it's nice that JavaScript has a proper module system now. So JavaScript has changed a lot, and I think Node has some problems. And it's kind of debatable about whether they're that big of problems or not. But it has, I would say the module system is not well designed. As I said, it's kind of tacked on as necessary. And it has this centralized repository where we're putting all of our code, right? This is working, and this is how other programming languages work, of course. But this is JavaScript. This is the web. It's supposed to be very distributed, right? And a centralized system where we all have to go to for our code is not very webby. And there's a lot of legacy APIs that were developed a long time ago. Namely, like all these file system stuff are generally built around the callback model versus the async model. And just kind of untidiness of the API that has developed. And I would say untidiness in the infrastructure too. But I don't want to go into that, like JIP and the way that you build third-party module or built-in modules. And then there's this security aspect, right? So JavaScript, unlike Python or Ruby, is actually a secure sandbox. The API that V8 gives you, to a first order of approximation, allows you to execute third-party code without trusting it, right? You can go to a website in Chrome and not trust that that code is not going to, load your SSH keys or whatever. So in Node, we of course have ways to open files on the disk and stuff. And so like any sense of security that you might have had is out the window because like you can just open files anywhere, right? So you could potentially do better here by kind of having some flags about some kind of better permissions. And I would just say that I spend my professional life generally in kind of native languages like C++ and Rust and Go, but dynamic languages I think are super important. I think there's no matter how much of a C++ programmer you are, you're always going to be scripting some stuff, right? You're going to rename a directory of files. You're not going to like break out C++ and like try to write a program to rename all these files, right? No, you're going to break out Ruby and just, or JavaScript, right? So I think that it's really important that we have a good tool for doing dynamic scripts. And I don't think that this tool is something that's going to be used for every problem, right? If you're writing a database, you're going to write that in C++. If you're writing a Nginx web server, you're going to write that in C or whatever, right? But I guess what I'm trying to express is that dynamic languages are very useful. They're not going away. And I think that this is an important enough problem that we should attempt to do it correct. And so this project is kind of my attempt to make my dynamic language workflow the way that I want it to be. So it's opinionated in some way. And so Deno's trying to do this by breaking compatibility with Node. Okay, so it's not attempting to run Node code at all. And it has to do this in order to kind of explore the space of possibilities, right? If you're trying to be backwards compatible, then that puts a lot of constraints on where you can go. So I would guess the kind of main features of this is that it uses ES modules by default. And there's no require. It's only imports, right? So it completely switched over to this new module system. There's no actual npm packages or anything. What you can do is you can import URLs. So have you guys tried this in web browsers? You can actually do import URL and load code via the ES modules remotely, assuming cores, headers, and stuff are all set up, right? So yeah, this is I'll show you a demo. And yeah, so Deno is trying to be secure by default. I'll also try to explain that. And it's also trying to be a bit more browsery, right? Node wasn't very browsery at all. Kind of just as need be, we invented APIs. And these days, there's a lot of browser APIs, and we're trying to stay true to what standard bodies have suggested. So I would say the core design around this, and this is wildly simplified, is essentially we have V8, and we've got some code running inside of V8. And we've got kind of the Deno code base, which is in Rust. Okay? And the only way that these two guys interact is through message passing. And they can only message pass uint8 arrays. Okay? So they can basically pass back and forth some binary data. And everything is built on top of this idea. These message passing things are called ops. And yeah, in some way, you can think of Deno kind of like an operating system. And the ops, these kind of calls out of V8 and into Rust land, where you're sending out a uint8 array, and you get a uint8 array back, all native calls are built on top of this. There's no binding layer. And these are called ops. And this is essentially the equivalent of a syscall in an operating system. You're jumping out of the VM, right? And in operating systems, you have file descriptors, right? A way to reference open resources, like an open file is assigned some integer ID. We call these resources just to not confuse them with actual file descriptors. And those are called, yeah, RIDs. So yeah, enough talking. Let me just break out the terminal and show you whatever I'm talking about here. So the question is, can you see that? OK. So here's Deno. It's a command line utility. And if you type it without arguments, you get a little prompt, just like Node. So you can do REPL stuff in here. And let's take a look at this. If I do ls -l-lh, which Deno. So let's look at this file actually. So this is an executable file. It's 48 megabytes apparently on my machine here. This is an actual executable file. And if you know what this command does, then you can appreciate the output of that. I'm not sure why this is taking so long. Oh, OK. So it dynamically links to two libraries. So it's a relatively self-contained thing. Deno ships a single executable and only will ever ship a single executable. So everything is in this file. And when you have this executable file, you can run any Deno program. OK? So yeah, let me start up this prompt again. So again, we can do some JavaScript here. And we have this, this global object. Actually, well, let me first show you the window object. So again, we don't have, we try to be browsery. So we do have the window object here. And what's in here? Well, I don't know. There's URL, blob, fetch. Fetch is built in. But in particular, there's this guy, this capital Deno object. And if we look in there, there's a bunch of functions and stuff like, CWD, current working directory. So let's try that. OK. So these are all kind of the native functionalities that Deno comes with. And Yeah, it's a flat namespace. So there's not like an FS module and a net module and stuff. This is essentially a POSIX API, and so we kind of use POSIX terminology. And POSIX is generally a flat namespace, right? Because C doesn't have namespaces. And I don't know. There's not an infinite number of things that we're going to add to this. So I think a flat namespace makes sense. Let me show you this. Metrics. So can you see that? So Deno metrics is some internal metrics, right? That we're keeping, and maybe we can display this a little bit easier if we do console table Deno metrics. Okay. And so it has this ops dispatched and ops completed. So I was telling you that like everything's kind of encoded in these ops. And so because of that, we can kind of inspect the system in kind of nice ways. These are really nice debugging tools. So if I run this again, notice that the ops have jumped by 2. So apparently to display this new message, it took 2 ops, right? And it's telling you some other stuff, which I won't go into, but basically, how much data has been transferred in and out of the VM. These are nice utilities to have. In Node, there's no such thing like this. Node is bound all over the place, and there's no kind of centralized information about what's going in and out of the VM. Another nice kind of thing about this, I mentioned that we have ops and we have resources. Ops are kind of like the function calls. Resources are like file descriptors. They're resources that are open files, open servers, whatnot. So let me print the resources. OK, so move that to the top. Yeah, so there's a couple common file descriptors here. Again, resources and file descriptors are essentially the same thing. We've got standard in, standard out, standard error. This weird one called worker. Who knows what that is? And 4 is the REPL. And like POSIX, you can kind of close file descriptors, right? So deno.close. Let's just try to close the REPL, which is number 4. And it crashes, right? As one would expect if you close your REPL, right? Yeah. So what did I want to show you? Oh, yeah. So let me write a little program here in the small amount of time I have. Let's write a little cat program here. So this program is going to take a file name and print it to standard out, OK? And so let's just start. I like to start off with some console logging. Hello, just make sure that we know what the hell we're doing. Deno cat. Got to save that guy. OK, that works. So let's print deno.args. And that would give you the command line arguments. And what I want to do is cat a file, like etc password. OK, and so what we're going to do is extract that file name there. So I'll go like let file name equals deno args1. OK. And let's try to open that file. How do you open a file? Well, you do deno.open. Very POSIX-y. And deno.open is an asynchronous function. Again, deno is obviously asynchronous. It has to be because it's a single-threaded runtime, right? And unfortunately, we can't do this at the top level. We have to kind of wrap this in async function. So in order for me to do like awaiting some function, I need to wrap that because I can't do it in the top level. Do you know what I mean by that? Good. Like explaining that, I'm like, OK, nobody knows what the hell I'm talking about. Sure. All right, so I'm just going to try to open that file and console log it and see if that works. That console logged the file. Oh, I got to actually call main here. OK. All right, so when I call this, it gives me this weird prompt. It says, Deno requests to read access to EDC password. Do you want to grant this? So this is what I mean about security. Like by default, it's not going to allow you to open EDC password. Who knows what EDC password is? I'm very old. Great. OK. One of my first programming when I was a kid and wanted to be a hacker was like logging into my local ISP where they had everybody, the EDC password like literally contained all of the users' passwords for this ISP, and the actual checksummed or whatever guys in there, and then you could just run like a brute force password cracker and go through and just you get hundreds of passwords like very easily. It was insane. Anyway. These days, there's nothing in EDC passwords. They fixed that. So the way that you can work around this is you can do something like Deno -- allow read gives you read access. And so that kind of allows you to sidestep that password prompt or that permissions prompt. Or you can just say, always allow, and it will also continue, kind of interactively go through that. So yeah, note again, if you can see it, this has printed file RID number 4. OK, whatever. So to print this to standard out, I mean, of course, we have read file sync in Deno. OK, you can read file sync and load this all into memory. But let's pretend that EDC password is 4 gigabytes big. Okay, we don't want to load this all into memory at once. We want to stream this to standard out, right? We don't want to blow up our memory and then dump it to standard out, right? That would be a bad implementation of cat. So cat does streaming. And the way that you do this is you read a chunk at a time. So you want to read a chunk of that file and then write it to standard out. Read a chunk of that file and write it to standard out, right? And kind of the real optimal way to do this, if you're in C, you can allocate one buffer for 4 kilobytes, say, and you can read into that buffer and then write out from that same buffer. Like you don't need any other allocations. You can just make one single allocation, read into it, write out from it, read into it, and write out to it. OK, all right. This is very important. Like it might not be important in kind of your day-to-day work, but it's important to make sure that it's possible to do these sort of optimizations. And I think that this sort of proxying action, where you have a single buffer, is more common than you might think. In particular, imagine you're writing a TCP server and or a HTTP proxy, and you kind of have connections going in, and you choose some backend server, and you want to proxy these connections. You might want to do this in a very optimal way, right? So anyway, Deno has this function called copy, which is stolen from Go, which does exactly this. It allocates a single buffer. It reads into it and writes out to it without ever allocating more than that. This is a 0 copy. OK, so we don't need to load. EDC password on my computer is very small, so this is a bad example. But imagine this was super huge, right? Gigabytes. We don't need to load this all into memory. We can do this with a single allocation. So what you do is you do copy. The destination is deno.standardout, and the source is deno file, right? And so we'll just wait for that, and then at the end of that, let's say done, just to see if it works. So I'll run it again. Again, I get this password prompt. We'll say allow always. OK, and so it's printed it out. Yeah, this is just to give you a flavor for Deno. So I mentioned it does TypeScript. These have been JavaScript examples, right? So one thing I would like to point out is that we know what our runtime is. Deno knows what its runtime is. So Deno types will print out this crazy file. And what I'm going to do is pipe it into Vim, okay, so we can actually see it. And I'm going to do set file type TypeScript. Okay, this is a d.ts file, a TypeScript declaration file. Okay, and it completely defines, so here's the Deno object, right? It has a PID, has an XPath, has ET, so it has all the functions in Deno, right? And I don't know, if I jump to the bottom here, I don't know, here's declare namespace WebAssembly. What's that? I don't know. Here's performance, here's workers. Okay, so I guess my point is that this Deno types output completely defines what this executable ships and all of the functions that are possible in there. And so, you know, it's not a matter of HTML documentation about what is being run. This is literally what is being run. So yeah, I don't have that much time, but let me just show you a program, a bit more of an advanced program that's located at a URL. So Deno, in some way, is kind of like a browser for scripts. And so you don't necessarily need to download a script to your local computer in order to run it. So you can have your script on your local computer, and you can import remote URLs. Okay, but you can also run scripts that are remote without downloading them. So what I'll show you is there's this program at denoland/standard/http/fileserver.ts. Okay, this is a program. I feel like I have to move that up for you to see it. So this is some program. It serves your local directory. It starts a HTTP server and allows you to see the files in your local directory, right? So let me run this guy. And it says, oh, Deno wants to allow network access to listen. I'll say yes. And it's saying, oh, now it's listening on this thing. Let me just curl that quickly. And it's going to be like, oh, Deno wants read access here. I'm just going to allow that always. And as you see down here, like there's some HTML that got printed out. Let me just do this over here, just to prove that it works. 4500. Uh-oh. Oh no. Demo's failing. Let's try this again. I'm going to do this -A, which kind of bypasses all permissions here. Oh, there we go. OK. So yeah, this serves the local directory. There's the cat.js file that we made. And yeah, I mean, I'll just leave you with this. But let me just show you, even if your Deno is not, you should not use this, right? This is very experimental. But we're kind of trying to build some tooling around ES modules that may be useful to just people who are writing websites with ES modules. So one of the things is this Deno info, and just tells you about that URL. And so one thing it does is gives you the dependency tree, which maybe if I make this a bit smaller, it's a bit easier to see. So it can tell you, oh, this file server file imports this file, and that imports this file. And here's all the files that it imports. And can tell you where that thing is compiled on your computer and stuff. So like I said, it's experimental. We're building some tooling around this. I'm out of time, so I'll just slide through all that and say thanks. Yeah, I don't think there's enough time to ask questions right now, but I don't know. I'll be at the drinks stuff, and I don't know. Maybe we can chat better then. So.